This is the solution to test number 1, version C for EE206, circuits 1. The first problem is Kirchhoff's voltage law that just says around any closed path, the voltages have to add to 0. So given this circuit, if I want to find V1, let's say, find a closed path where there's one unknown, like right here, and I get minus 100, minus 37, plus 38, plus V1, plus 78 equals 0. Solve for V1, and you get 21 volts. To find V2, here's a path with one unknown. So minus 100, minus 37, plus 38, plus 37, plus V2, plus 46 equals 0. Or now that I know V1, I can just do this path. Minus 32, minus V1, plus 37, plus V2 equals 0. Likewise for V3, V4, V5, and you should get these voltages. On problem 2, this is adding resistors in series and parallel. This is where an HP calculator really shines. For example, to figure out these voltages or resistances, I would have 570 in series with 650. So it's 570, enter 650 plus. That's 1220 ohms. And parallel with 700, 1 over R1, 1 over R2, that's 444 ohms. In series with 510, 954 ohms. In parallel with 720, 1 over R1, inverse of 720, gives you 410 ohms. Now, in series with 120 and parallel with 540, so here's 120, inverse, 540, inverse, add inverse, that's 98 ohms. Add the two together, I get 508 ohms. Problem 3. In this case, given the voltage, V2 is 100, find the other voltages. V3 is fairly easy, just use voltage division. These two resistors in parallel give you 132 ohms. Then by voltage division, V3 is R1 over R1 plus R2 times V2. I know V2, solve for V3. V3 is 72 volts. Likewise, if I compress all these together, I can find V2 as a function of V1 by voltage division. Compress all those together, I get 153 ohms. So V2 is 153 over 153 plus 45 up here. That percentage of V1, I know V2, solve for V1. Similarly, compress all these resistors plus that 390, and I get 131 ohms. So V1 is a function of V0. I know V1, solve for V0. So these are the answers you should get for problem number 3. Problem number 4 is current division. If this is 100 amps, I know 100 amps times 100 ohms is 10,000 volts. I can compress all these resistors together and find out the current through that 20 ohm is 107 amps. So 100 plus 107 must be IA. IA must be 207 amps. This current, 107 amps, splits. 150 ohms here, take all this resistance, and it gives you 141 ohms. So the current through the 150 ohm resistor is that percentage of 107, 52 amps, leaving 55. Then by current division, of that 55 amps, this much flows through the 200 ohm resistor. The remainder goes through the 250 ohm resistor. So this should be the answers for problem number 4. Problem number 5 is write the voltage node equations. Here start with the easy one. The easy one is V3 minus V4 is 10Vx. Vx is V2 minus V1. I got these backwards. Next, I need 3 more equations. At node 1, current left, current down plus current right equals 0. At node 2, current left, down, right, and up equals 0. And note the current up is minus 2 amps. V3, I can't write the node equation, or V4. I need one more equation. That's a supernode. Take any closed path. The current out of that closed path has to add to 0. And for this case, the supernode is V1 over 50 plus V2 over 250 plus V3 over 350 plus V4 over 600 equals 0. The last problem is current loops. I have 4 loops. I need to write 4 equations, 4 unknowns, plus Vx gives you 5 equations, 5 unknowns. Start with the easy ones. I1 is minus 2. Vx is 100 I2. Then for the last 3 equations, I can just do sum of the voltages around V2, sum the voltages around I3, sum the voltage around I4. All those have to add to 0, gives you 5 equations, 5 unknowns. So that's quiz number 1, version C for EE 206 Circuits 1.